All right. The title is Similar Triangles Postulate. So what we're doing today is we're going to prove that triangles are similar using these four postulates. Can somebody check that, please? Using those four postulates. So here we have side, angle, side, angle, angle, side, 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 and the last one is angle, angle, angle. So these are the postulates that we're doing in class. Can't do it now, I'm teaching. Alright, so here's the idea. Whenever we have similar triangles, all the angles are congruent. Angles are always congruent. All the angles here, it's the same there. But the sides are not the same, they are proportional. The only time the sides are the same is when it's the same size, it's already congruent. But apart from that, they are proportional, meaning the ratio between the corresponding sides will be the same. Now we're going to start to see which one of those can help us to prove that these set of triangles are similar. Let's go. Case 1. So in case 1 here, we're looking at the fact that we have two triangles. Now, whenever you're doing similar triangles, you're going to have to look at the information you're given. So if you take a look at angle C, you notice that we have two strokes on the angles right here. And angle T, we have the same two strokes here. That is sending a congruent message. This is saying that the angle at C is congruent to the angle at T, because you're seeing the same notation where the angles are. Everybody see that? So already we have what is called an angle out of the idea where we have corresponding angles being congruent. Now, outside of that, we have some sides. So we have two sides here, two sides here. What we're going to do now is that we're going to compare the sides. But whenever you're looking at the sides and you have the value for the sides, we're going to compare them in terms of size. What do I mean? The smaller is 9, the larger is 10. The smaller is 27, the larger is 30. If they are similar, it means that 9 is corresponding to the smaller one here. 9 is the smaller, it has to correspond with the smaller if it is similar. Also, 10 will correspond with 30. Agree? In terms of size, if they are similar. We will take this idea, our color code green and our blue, and we're going to set them up to look if they are proportional now. And if they are proportional, so side, angle, side. Let's see. I'm going to put these at the bottom. So this is my decision. I want to put these at the bottom of my ratio, and I'm going to put these at the top. There's no real reason to do it. You just have to be consistent. So I'm putting everything from this diagram at the top and everything from this diagram at the bottom. So what do we have? 30 over 10 or 30 to 10 in terms of a ratio. 30 to 10 is equal to 27 to 9. We're talking about the largest one here as a ratio of the largest one there should equal to the smaller one here as a ratio of the smaller one there. Let's see if we get the same value. If we do, then we would have nailed it. 30 divided by 10 is 3. 27 divided by 9 is 3. They are equal. So we are seeing now that the corresponding sides are proportional, which means that we have side, side. So the deal is side, angle, side. That's what we're saying. We're saying that we have proportional sides and an angle between them. So the postulate that just proved that they are similar is side, angle, side postulate. So that's the side angle side postulate right there. Is that clear? Now watch this now. I am going to want us to write a similarity statement at the end every time, right? So I want a similarity statement to be written every time. So already I started off by saying triangle TUV is similar. So this is already started. What we need to do is to find the corresponding idea that flows with this. Now let's start off. T is where the angle was given. So naturally, T would be corresponding to what point here? Anybody? C. So we know that triangle C is where we're going to start. Now let's watch the flow of what we got. Take a look. TUV. TUV, we went across the longer side. Look, T to U is across the longer side. True? That means you got to go across the longer side here to make sure that you're dealing with it as a similar idea. So you can't go across the 9. No, you got to go C, D, E, because we went across the longer side from this diagram. We have to do the same from the other one. So it is C, D, E. See that? So quite easily you can make the error if you just write down the things. You can't. You have to make sure that you flow in the right way. So from T, we went across the longer side to U. So from C, we must go across the longer side to D, and then that's it. So this is our similarity statement here. Is that clear? All right. Let's look at the second postulate. Number 2. We want to prove that these are similar. Firstly, when you take a look, you do realize that you got two same angles already. So we got two congruent angles. So we got this angle here that is equal to that angle there. So already I have what is called angle. That's a start. But when we look, there's nothing else, right? We don't have any sides, and we don't have any more clearly labeled angles. So I'm going to say this to us. Does anybody remember whenever two lines cross like this? Whenever two lines cross like this, what type of angles are formed? Two straight lines just cross. Anybody remember? You would have done it at 7th or 8th grade. They just cross like this. Doesn't matter, as long as they cross, something unique happened. Like this. Two straight lines cross past like that. Right? That's a part of it. She said opposite, but that's a part of the whole thing. There's a V word that's missing. Anybody remember? Take a look. It's called vertically opposite or vertical angles. Anybody heard that before? Vertical angles are congruent. So as long as you cross, two lines cross path, this happens. This is where they cross. This angle that opens to the right is congruent to the one that opens to the left. Which means if this is x degrees, this is also x degrees as well. Also, the one that opens upward is congruent to the one that opens downwards. So we call them vertically opposite angles. So if this is y degrees, this is also y degrees. So that is what we're going to embark on here. Everybody see that the two lines cross here? Look, this cross here. They cross here at H. Because of that fact, this angle here is vertically opposite to this here. So they are congruent. Which means if this one is x degrees, this one is also x degrees. So which would have meant that we have two congruent angles now. You agree?
Yeah.
We don't know what the value is, but it's not about the value, it's about the principle. Right? So these two angles now are equal, which means that we have congruent angles. So think about this. How many angles are in a triangle? 3. And if we just realize that 2 are already congruent, isn't it unnatural that the third one will be the same? Because the total interior angle will go 180. So if these two are the same already, then the third one is naturally the same. So we don't need to prove that. That's what we're saying. So that is why the postulate says, if you have angle, then you could stop, because it's a natural that the last pair would have to be the same, because they both will be adding to 180. So angle postulate is what we have here. Angle. So they are similar. Even though we don't see any sides, we know they are similar based on the ideas. Angle. Now, how could we write our similarity statement? They already gave us angle HGF. So now we're going to have to take a look on this. HGF. How do I write the similar stuff to this? We know that it's going to start with triangle H. Triangle H something, because we're coming from right here. So H, somebody says T. I like that. So it's going to be HTS. Exactly. And the reason why it has to be T is because look at what we got first. We left H and we went to G, which is the 61 degrees. Make sense? So that means when we left H here, we must go to the 61 degrees. But this 61 degrees is at T. That is all. So we're talking about following that pattern. From the first one, make sure you replicate the same pattern, the same walk, the same path for you to be right. If not, it's going to be incorrect. Is that clear? Let's take a look at the third one here. Number 3. For number 3, for this one, we only have sides. There is no angles that were given. Right? So we don't have any angles here for this one. So number 3, we have 3 sides, right? Now, what we're going to do is to observe. We're going to look. There is a side postulate. But we must make sure that we are linking ideas. So if I were you, what I'll do is I'll link them in ascending order. Meaning, I'm going to color code them. So I'm going to say, from smallest, 15, must correspond with the smallest from the other diagram. We can't go around that. The smallest side from this diagram must correspond with the smallest side from the other diagram. Let's take out green. The largest from this diagram must correspond with the largest from that diagram. So what I'm doing, I'm isolating corresponding sides, because we're going to set them up as a ratio to see if they are proportional. Lastly, 70, right? 70 is in between. 25 is in between. Are we good with the setup in terms of the color code right there? So what we're going to do now is to use this to help us to see if we have them being proportional as it relates to corresponding sides. Now let us set them up. I decided that I want to put these ones at the top from this bigger diagram, and I'm going to put these at the bottom. So I'm going to set up my corresponding sides as a ratio right now. So let us start by saying 84 should say, over 30. Make sense? 84 is the largest from this diagram. 30 is the largest from the other diagram. So I'm saying 84 to 30. That's the ratio. 84 to 30 must equal to, I need another one. Can somebody give me another pair? 70 to 25. So 70 to 25, which should equal to, lastly, 42 to 15. Now take your phones or your calculator out and give me decimals for this right now. All right, so this is 2.8. Let me see what we got for this now. 2.8 again. Let me see what we got for this one too. 2.8. So we are seeing here that this is very unique. We took the largest side coming down to the smallest, and we connect largest with largest, smallest with smallest, and the middle one with the middle one here, and we wrote them as a ratio. We were consistent with which diagram we put the things at the top for, right? And we realized we got 2.8, 2.8, 2.8. This is what we call proportional. This is equal to this, which is equal to this. And that is why we were using the idea recently to solve problems. Remember we used 4 of them, and we did a cross multiplication to solve problems, because we knew that the ideas are similar, which means that they are proportional, so we could set it up, and if one is missing, we can figure out the other one. That's what we have been doing. All right? So now we see that they are proportional by this postulate. S, 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 they are similar by the postulate of side, side, side. So side, side, side told us that they are similar. Is that clear? Everybody clear? Is it clear? Yeah. All right? Now, we want to write a similarity statement. So I'm going to start it off, and you are going to finish. Let us see. So I'm going to start off a similarity statement. For example, I'm going to say triangle, let me say I use QSR. So I am saying QSR is similar to who? Now you're going to have to look. Connect Q to a similar or a corresponding point here. So you got to look. Q here does correspond with some point here. Remember, not because I started off with Q here means that V corresponds. You got to look at the orientation of the diagram. You got to look at the diagram itself. This diagram does not set like this. This one was turned down, or so sometimes you got to think, what if I turn the diagram to suit how I feel, right, in my mind? So you got to find the connect. Can anybody give me the connect for this? What's the connect for Q? Which one of these spots is the connect? T. Very good. So it's going to start off with triangle T, and then from that, watch my pattern and flow accordingly. So I went from Q along the smallest side to my next point. Agree? So that means I have to move from T along the smallest side. So I can't go along 70. I have to go along 42 to V. So it's going to be T, V, U. That is all we're saying with this topic. One has to look, and you have to move the right way. You get it? You get what I said or not? You good?
Yeah.
Okay.